In this video, we're going to develop a custom processor for RAMP. So something that you can write using the .NET framework and then plug into RAMP and make it available to the RAMP user interface, the RAMP command line processor, to the workflow processor, and to other utilities that might want to use it. So we're going to assume a certain competency in terms of entry requirements for this tutorial, and the first is that you're familiar with developing .NET applications using the C# programming language within Visual Studio, and you understand the concepts of polymorphism and how interfaces work in the .NET framework. If you're unfamiliar with any of those, then this video tutorial is probably not for you. I would encourage you to go and look at some of the other online video tutorials that are available on the web that might help you get a better understanding of some of those concepts. So specifically through example, the objectives of this tutorial will be to firstly understand how processes in RAMP actually work, and then to implement the RAMP iProcessor interface, which we'll come to a little bit later in Visual in C#, and then to write some processor methods that will do some very simple things. So we'll do a very simple hello world example. We'll print whatever the user tells us to print, and we will print the number of rasters that are maybe given to us, and then we'll also repeat the number of we'll repeat out whatever the input rasters are. We'll give them as outputs as well. So these are very simple methods that should allow any .NET developer the ability to get started developing custom RAMP processors for RAMP. So first we're going to look at what a processor actually is, and let's go to the RAMP graphical user interface to do that. So in the RAMP user interface, when I click on the processing sort of folder, it says processors are generic collections of methods that generally but not exclusively process rasters and or create new raster projects. So let's have a look at just clicking on a very basic. Let's go to local statistics, and let's click on the range again. Each processor contains a series of methods, so each of these is known as a method. And a processor in a .NET sense is a single class that exposes a set of properties that dictate what these processor methods are. Each processor method in itself must have a series of what we call properties, and these properties can have different data types. There must always be a property called method, which has a fixed value type, and that value, the value of that type, should be the name of the processing method within the processor. So again, if I look at the local statistics processor, it contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different methods, and they all have specific method names. By convention, these are all capitalized, and they have an underscore between words. That's a convention that is not enforced, but is highly suggested. Okay, so we know that a processor contains multiple methods, and each method contains a series of properties. What we're going to look at next is how it exposes that information, and we're going to go switch to the programming documentation now to see actually what a processor is. So if I go to the API reference documentation, the simplest way to describe what a processor is to say that it must implement a particular interface that is available in the RAMP namespace or the RAMP core library, and that is the iProcessor interface. So if I click on iProcessor here in the documentation, it tells me, okay, I'm defined in the RAMP core library, and my namespace is ramp, and I have a particular, I'm an interface, and my name is iProcessor. And I have a series of different methods and functions that if you implement me, you must implement. So if you're not familiar with implementing interfaces, again, I suggest you go and have a look at some of the tutorials that might be on the internet that explain how you implement an interface. So essentially, we've defined an interface in the ramp core libraries, and if you want to create a processor, you have to implement the same interface. And it's very simple. There are three specific properties and one function that you have to implement before before anything that you develop is deemed to be compatible with ramp and therefore can be consumed as a processor within ramp or within ramp proc or whatever utility it is. So the basic idea of a processor is that it exposes an array of property sets, which are known as the property set signatures. Each of these property sets defines an individual method. So when you construct your own processor, you have to also construct all these property sets that you would like to expose so that ramp can say, oh, okay, you've got method A, method B, method C. The second property here is the specific property that the user has decided to execute and has set all of the values within that property. So let's just go back and look again at, let's pick a different processor. Let's look at something like the terrain analysis processor. So that processor, if I double click on it, has exposed a series of property sets. So each one of these methods is actually a property set. And within each property set, it contains a series of property items. And again, we talked about those before. Each of those items has a particular type, etc. So going back to the API documentation again for iProcessor, this is the collection or the array of property set signatures that define the methods that are available. This is the one that the user has set and selected and provided values for each of the property set items within that property set. And then the processor is then given the available rasters that can be selected for processing. So this is the array of rasters that are either within the ramp graphical user interface or they are provided to it by ramp flow or ramp proc or one of those other utilities. Finally, you would execute a processor and it would process whatever the property set that you have said is the current method to execute and return an array of rasters. So not all processors have to take rasters as input. So this can be null or it can be an empty raster array. And similarly, not all processors have to return rasters. So the return can be null or an empty array of rasters. So if you look at iProcessor from a object entity type relationships perspective, you have the property set signatures which expose all of the methods. So that's read-only and it contains many property set objects, which in turn contain many property set items. The property set attribute of the iProcessor is a read and write attribute that can contain only one property set object. The input rasters you can both get and set, and they may contain more than one, 0 to 1, actually, that's incorrect, that should say 0, 0 to 1 output rasters. And then when you finally have set the specific property set that you want to execute, when you call execute, it returns 0 to n raster outputs. So that's kind of the way that a processor works in ramp. So in the RAMP API documentation, you can also see all of the methods and functions that are available to the property set object, the way that it can serialize and deserialize from XML, the way you can access individual items in there through calling the item function, how to get particular values, etc. We'll look at these in a lot more detail when we actually practically go through this. But the documentation is all here. If you want to understand any of those functions and methods, you can by reading the documentation. The same is true for an individual property set item. Here are all the different properties or attributes within that, and the various methods and functions and constructors that you can call to create a property set item. But we will do this by demonstration, so you don't need to freak out about what all these things mean. Right, so let's start our demo, and we're going to start Visual Studio keeping in mind our objectives, which we'll look at in a second. So let's start Visual Studio and let's create a new C# DLL project. So in C#, I'm going to click on Create New Project, and I'm going to choose a .NET Framework class library as my project type. Click Next, and we will call this ramp processor, ramp custom processor. Let's do that. Or let's call it ramp tutorial processor. I really haven't made up my mind there very well. Alright, so let's create Next, and it's going to go through and it's going to create a template project that is suitable for, suitable for creating a DLL. Okay, let's go through here, clean up all the crap that we don't need. So I don't need that. My namespace is ramp tutorial processor. I have a class in here that's declared public. I will rename this to tutorial class. And what we will do, we'll also rename the file to tutorial class. I like to keep my file names and my actual class names the same. And then what we're going to do is we are going to add the ramp core DLL to this particular project. So let's do that in references, add reference, and I've already got it here, but what you can do is you can browse to the location that you've installed ramp and just pick the ramp core DLL and add that. And then what we're going to do is we're going to tell it that we're using ramp. As you'll know, now what we need to do is we need to tell C# that we intend to implement iProcessor, because that's what we need to do in order to make this particular class, the tutorial class, act like a ramp processor. So tutorial class implements iProcessor, and immediately it's basically said, hang on, you haven't implemented execute, property set signatures, property set, or input rasters yet. Let's take this one by one and look at what modular variables we might need to declare before we can make some of these properties and methods available. So firstly, I'm going to need some modular variables, and I'm going to cut and paste them in from here. And these are the variables that I will later expose as properties. But I need an array for every property set signature that I'm going to make available, and we're going to use, if I look at my objectives again, we're going to have 4 different methods defined, so 4 different property set signatures in there, one for hello world, one for user input, etc. So we're going to need an array to house those, and we're going to need a property set object that stores the user defined property set before we call execute, and then I'm going to also need to define an array of raster objects as the input rasters to this processor. So these are my modular variables. They're private scope, so they're hidden, and later on I will expose those as public scope. So the next thing that I need to do, like in any project, is create the constructor for the tutorial class. So that's going to look a little bit, that's going to look a little bit like this. So let's go constructor follows, and I'm going to say public tutorial class. That's my constructor, and I'm not going to pass any options to it. But what I need to do now is I need to populate the property set signatures. So what I'm going to do is I'm going to create a list. Can't do that because I haven't defined using system.collections.generic. I'm going to create a list of property set objects. Yep, and I'm going to call them prop set. Oh no, I'll call them prop set signatures. Okay, and I'm going to initialize that as an empty list of property sets. Okay, now I need to go through, so let's comment this. Create an empty list of property sets that define the signatures of the methods. Okay, the next thing I need to do is create the individual property set signatures. So what I'm going to do is I'm going to create a new property set object. So property set, and I'm going to call it prop equals new property set. So you can see that there's a number of ways to instantiate property set. I'm going to create the default one, which is going to be an empty property set, and then I have to give it a name. So what is a name? Let's go back to RAMP and look at what names are in a property set signature. So again, I'm going to pick on, let's pick on the terrain analysis and double click on it. So the name of a property set is what you see here. So in this case, it's slope directional. It's a familiar name that kind of works. And people look at it and they know exactly what it means. So that's what a name is. Let's go back to our code. And now we'll say property.name equals hello world exclamation mark. Or let's not do an exclamation mark. Let's just say hello world. Now, as we talked about before, every property has to have a property item called method. So let's just quickly look at that in the RAMP documentation. Every method has a property within it called method, and it has a type called fixed. So let's add a fixed type method, and we will call it hello_world. So let's do that first. So add, and it's asking me for, let's have a look, the name. So the name of the property will be method. The type of the property will be fixed, and the value will be hello_world. Okay, this brings up what different property types are available within the property set. So let's go have a look at that next. So the API documentation has an enumerator for property set item property type. And you'll see that it has a whole series of different types in there. So I can have integers, floats, strings. An input file defines a property set item as being needed a file path as an input. And the output file is similar in that it requires the path to a file that will be used to write to or to output to. The folder is a path to a folder. A raster is either a raster or it's some sort of reference to a raster. So that is very generally the index number to a raster in the input rasters. So looking at the objects diagram again, a raster is very often the actual index of the raster within the input raster array because it contains many. So that's what that is, and it's usually an integer, or at least it's serialized as a string, but it represents an integer. I have a kernel data type, which is actually just a path to a kernel file. Boolean, double, fixed. Input format, this is the list of all of the valid ramp input formats as strings. And if we click on here, we can see it's either one of these sort of values. Let's go back. The same with the output formats. An ellipsoid is the name of an ellipsoid that's defined in one of the ramp configuration files. You have how you can assign cells, so that's let's have a look. Cell assignment methods, so that's min, max, moving mean, replace, sum, count. So they're all fixed values. So that's all actually implemented strings. There's a whole bunch of stuff in here. Interpolation methods, lists, list options, and recently we've added the idea of a field and fields. So these are fields from a ASCII CSV file or a ramp profile file. It's just the name, so it's implemented again as a string. So these are all the different types of property set items that you can currently define. So the method one is always fixed, and it's just called hello world. We're not going to have any other methods in here, any other property set items in this particular method, because when we execute this, it is going to just print the words hello world. So let's move on and see what we need to do next after we've implemented the constructor. So this is where we're going to implement some of the properties, at least, that iProcessor expects. So again, as we saw in the documentation, it wants to have property set signatures, and all it's going to do is return the modular that we've previously defined up here. Let me try to make this smaller. Yeah, so property set is just returning m property set signatures. Property set is returning m property set, and there is a get and a set method for both of those, and this is for the input rasters as well. So all this is doing is satisfying the requirement that we have to have some public properties called these particular names. So you'll notice now in my error here, the only thing we have not implemented yet to satisfy the requirements of the ramp iProcessor is the execute function. So let's go and have a look at that next. So if we look at the documentation, for iProcessor, it must be void and return an array of rasters. So let's do that. So it is public raster, so it's not void, it returns an array of rasters. And it's called execute, and it does not contain any arguments, is what I meant. Okay, so what we could do now in here is let's look at the current property set. So what happens with the processor is that it makes its property set signatures available, and then the graphical user interface says, all right, user, what do you want? And then they pick something, set some variables, set some properties in there, and it becomes the m property set variable. So what we need to do is we need to select on the m property sets method, method property, I guess. So what we're going to do is we're going to say, let's do a string, and let's call it str selected method equals m property set dot. Now I can get the value of a particular thing. So I'm going to get the value of whatever was set as the method. So this should return, in our case, hello world, because it's the only property set we actually have in the signatures. Yep, but we're going to add more later, so it's good practice for us to do this. So let's put a comment in here. Execute the selected method. And then we're going to do a switch in here. So we're going to say switch str selected method, and one of the cases will be hello world. So this is what we need to do if we come across the method hello world. And what I'm going to do is, in this case, I'm going to use the ramp utilities function called out. So let's have a quick look at that. Ramp utilities, there's a function here or a method called out which displays a message. So let's do that, out, and we'll just say hello world exclamation mark break. Done. Actually, we need to return null from this because we're not actually going to return a list of rasters. So return null. Okay, that's great. And what happens if it doesn't know what the method name is? Let's just return null as well. Okay, so we've implemented, let's go back to the objectives. We've implemented our first, that was not it, our first processor method, which is printing hello world. The next thing that we're going to do is print whatever the user tells us to print. So let's have a look how we're going to do that. I'm going to go back up here and I'm going to go to my constructor, and I'm going to add something I forgot to do actually here was add the hello world to the M property set items. So we should have had that at the bottom. Add all of the property set signatures. So we'll say M property set signatures equals, and I'm going to take that list, prop set signatures, whoops, dot to array. So that returns an array of property set objects, which is what I want. So I need to put that at the bottom because I forgot to do that. And of course I also need to add it here, which I forgot to do as well. Prop set signatures dot add prop. That's better. Sorry, I've now added it to the list. Okay, so let's. So this is the one for hello world. Now we want to print, so we'll call this echo. Yeah, so we're going to create a new property set. So prop equals new property set, and the prop.name will be echo user input. And we'll add to that method because we have to, and it will be fixed because method is always fixed, not fixed, and it will be called echo. Now we're going to add to that. Now this is where the user gets to add their own input. So let's call this the string to echo will be the name of my property within the property set item, and it will be of type string. And what we can do now is we can define, if you look here, we can define a default value. So we'll just say, we'll call it hello ramp. And then I can also give a hint. So this is like a tooltip. So what I'll do is I'll say define the string that you would like to echo. And that's added that property set item to there. And now we will do the same. We'll add this new property that we created, or this property set that we created, to the property set signatures, and it will return to the array. Now what we need to do is make sure that we handle that case down here. So we need to handle case echo. And what we want to do is we want to get the string of we want to get the echo string. And in that case, it is going to be the property set get the value of, what did we call it? String to echo. Yeah, so get that value and then basically write it out. Echo string. Done. And return null to the caller. Alright, what we're going to do is we're going to build this in a second, and we're going to see how we will add this into the ramp GUI so that we can test it out. So let's go ahead and build. So build the solution, and the build has succeeded. So what we're going to do is we're going to go to the build folder, take that DLL out and actually put it into our ramp installation folder, and then we'll look at how we configure ramp so that that DLL is now available as a processor. So let's do that. So in my Visual Studio folder, I have, here we go, ramp tutorial processor was the DLL that it's just compiled, and you'll see that it's also taken some of the dependency files that it needed before. I don't need those because I'm going to put them back into the installation folder anyway. So let's go to the ramp installation directory, which is here, and we're going to paste in this ramp tutorial processor.dll. So that hasn't made that available to ramp yet. We have to tell ramp to use that DLL, and we do that through the tools.def file. So if I open tools.def in a text editor, over here, that's a bit large, you'll see that this is how we configure all of the processes and the folders and stuff in ramp. So all I need to do is I'll just add one to the top here. So under the processing folder, I'm going to declare a new processor, and it's not called processors.dll. It's called, I've lost it, ramp tutorial processor.dll. So here we go, ramp.tutorialprocessor.dll, and it's asking, well, what is the name of the object within there? So if we go back to our code, no, not that, our code, it is ramp tutorial processor dot tutorial class. Yeah, so that's the namespace dot the class name. So, whoops, ramp tutorial processor dot tutorial class, if I remember correctly. Okay, and now we can just give it a name. We'll just go, okay, we'll call it video tutorial. And the help file, there is none, so we'll just call it none.html. There we go. Right, if I save this now and I restart ramp, it should pick up this. So let's have a look at that. So if I start ramp up now, I can see under the processing folder, I have a new video tutorial processor. And the first method in there is called hello world with the method name hello world. If I click OK, what does it do? It prints hello world into the process output. Let's have a look at the next one. Echo user input was the next one. So if I just run that, it's going to say hello ramp, because that was the string to echo that I had defined in my processor's signature. Let's change that now to hello YouTube. Okay, and let's see when I execute it, and certainly it echoes hello YouTube. So they're two really simple methods. Let's go back to our code now and look at how we can interact with the input rasters and do something ever so slightly more complicated. So in our objectives, we said the next method that we wanted to write was going to print the number of input rasters that were presented to it. So let's have a look at how we might do that. So I'm going to create a new property set signature. So this will be echo input raster count, and prop equals new. So we're going to create a new property set, and the prop name will be echo input raster count, and we're going to add the method because we have to, and it is going to be fixed because it has to be, and this will be called echo raster count, something like that. Okay, we don't need to do anything else because if you remember, the processor gets sent the list of input rasters that are available to it. So all we need to do now is, let's add this to the list of property sets, and let's handle echo raster count down here. So we need a case where we handle raster count, and what we're going to do is we are simply going to put basically if input rasters is not equal to null, then we're going to output the length of that as a string. Otherwise, we're going to just say that it is 0/null. And then we're going to break. So that was really simple. Let's compile this, and now let's see what happens in the... So I'm going to build this. We're also going to put it back into that into the ramp installation directory and see what pops up next. Okay, so I've restarted ramp, and if I click on video tutorial, you can see I now have a new method in here, echo input raster count. So if I echo this now, it should say 0 because I have nothing in there. Let's go add a couple of rasters in here. Let's add this one, and let's add this one. Let's maybe quickly render them so you can see what they look like. Okay, cool. Now when I go to video tutorial, echo input raster count, and echo it, it's telling me I now have 2 inputs to my processor. So that was successful. We've implemented what we said we were going to implement in terms of printing the number of input rasters. Let's do another one now where we basically just return exactly the same number of input rasters as the return rasters is the same as the input rasters. Let's have a look at doing that. Okay, so I'm going to go create a new property set signature at the top here, and it's just going to be called echo rasters, and we're going to create a new property set, and the name will be echo input rasters, and again we'll add a method because we have to, and set item type will be fixed because it has to be. Always goes to field. And it will be called echo inputs. Whoopsie, inputs. Okay, again, we don't really need to do anything else because we're not asking for any other inputs from the user. We're just going to literally return the same number of inputs that it gave us. So let's go handle that. It's a new case down here. case echo inputs, and basically we're going to return the input rasters. That's it. Let's see what happens when we do this. So let's build it. Build succeeded. Let's now take that DLL, put it in the output folder, and restart ramp and see what happens. Okay, so I have it here, video tutorial, and now I can see the new method, echo inputs. If I click on it, nothing happens because I gave it no inputs. But let's go add those same rasters again, render them. We'll add another one as well. I'll use the same one as I did last time. That. So these are automatically going to be inputs to my processor. Let's echo them back out, see what happens. Now, interestingly, it's essentially created and output exactly the same data sets. Now, these are linked in memory, so it's very dangerous for me to ever implement something like this without actually cloning the rasters and duplicating them. But it's a demonstration of how processors work with by defining methods, by defining properties, by handling the method cases, and using input rasters and returning output rasters. So I hope this has been a very quick but overview introduction to developing plugins and custom processes for RAMP. Thanks for watching.